Muluvinaka guys, just a brief introduction about myself. I'm Geospatial Technical Officer with the Pacific Community GEM Division, Geoscience, Energy and Maritime Division, with the Maritime Boundaries team. So our project mainly works with maritime delimitation, so national jurisdictions, maritime boundaries. So this project is on a particular coastal state, and right now I'm just gonna present on the GIS and remote sensing tools that I implement in this project. So one of the three main objectives for this project is to map 3 nautical mile coastal zone. Sorry, this is a big stage for me, and I'm a bit nervous. Thank you very much for the organizers, the DP team, for allowing me to present and to come attend this conference. Moving on, the second objective is supports national policy goals for sustainable maritime management under the international guidelines, which is UNCLOS. The last objective is strengthens jurisdictional governance over nearshore waters, fostering economic resilience. So one of the technical part of the project only has 2 main goals. First one is to establish the low water line as the baseline, and the second one is to delimit the 3 nautical mile boundary. So this is the GIS and remote sensing methods. Firstly was the data acquisition and analysis, which is mainly open source. Satellite imagery, Sentinel-2, Landsat imagery, using open source platforms, cloud platforms like such as Google Earth Engine and Python. We derived multispectral and temporal data. And additional tools that were available to the project was the Digital Earth Pacific tools, the coastline tool, which showed the coastline change over the past 10 years, and also the mangrove detection tool. One of the major products that we wanted to derive was the bathymetry data, since we were dealing with coastal waters. Firstly, we tried using Sentinel reflections data, using the pixels to derive a water index to get the bathymetry of the water depths of bathymetry. The second way that we tried to advance, or maybe a more accurate way of deriving bathymetry, was the ISAT2 data catalog that NASA hosts. So using an API or NSIDC, you are able to use the ISAT2 data catalog with their laser that were able to penetrate the surface of the water. And we use the refraction correction method to correct once the laser penetrates the water, we use the refraction correction method to correct the laser. So as you can see, the graph on the side was done in Python. You can see it as a more accurate and more reliable output for us to use in the project. And also to enhance the accuracy of the satellite imageries, the team collected data points, and also we combined remote sensing with ground truthing to give us a more reliable data outputs. Also, we combined it with hydrocharts just to validate those bathymetry data that we derived using remote sensing. Then we developed a baseline, which was then inputted into a software under the Law of the Sea framework and guidelines, which then delimited the 3 nautical miles for that particular coastal state. Thank you so much, Sunaka.